Thank you. So here are you. The voices belongs to you. At the beginning, you have no voice. I think in a few minutes, maybe the second or third minute, we start hear the voice.
The methodology used in this work is focused on the analysis of three devices as classified as spectral element method, and transfer matrix method, and resonant shunt circuit. These formulations are used to represent the beam structures of Euler-Bernoulli and Timoshenko, and beam with one and two layers of piezoelectric coupled. For the beam one piezoelectric structure, we have the Euler-Bernoulli theory, and for the beam with two piezoelectric, we have Timoshenko theory. The configuration series in connection resonant shunt and configuration parallel connection resonant shunt. The formulation for beam with the coupled layer of piezoelectric, it can be obtained from the coupled relationships of a beam element with the bar element, representing the piezoelectric. The cinematic relations associated with the constitutive relations of the piezoelectric material can express a general equations of motion. To solve the motion equations, we use the general solution that carry the amplitude and wave propagation. The K is wave number. Solving the equations, we can arrive at the expressions of the spectral stiffening matrix, where the vector is displacement and forcement. For simplification, the spectral stiffening matrix of the beam with a coupled layer of the piezoelectric can be expressed with the terms of matrix displacement and matrix the forcing matrix. The formulation for beam with two coupled layers of piezoelectric, similar to the case for beam with one coupled layer of piezoelectric. However, it has the shear effect, the linear constitutive relationships, so the piezoelectric the shear effect. The equations of motion is expressed with. Solving the equations of motions, we have the solution general, and the vector is the wave propagation and the vector the amplitudes. For the obtained the spectral stiffening matrix is given by, and the other relationships between force and displacement can be represented with. For simplification, the spectral stiffening matrix of the beam with two coupled layers of piezoelectric can be expressed with the terms displacement matrix and forcing matrix. The formulation for resonant shunt circuit, we have the connection of shunt electrical circuit to the piezoelectric is given by a matrix stiffening rigid for structure and matrix stiffening rigid for shunted circuit. The impedance of the shunt circuit are associated with the specific resonant frequency with the inductor and capacitance. The admittance resonant circuit shunt and impedance the resonant circuit shunt. The boundary conditions instruction is free. The properties adopted are described in the table. The results represent area impedance, the frequency response function, and the dispersion diagram. The attenuation effect is similar to the effect of dynamic absorber and occurs exactly at the frequency the impedance design. The dispersion diagram shows the attenuation effect in the transversal way and mode and the longitudinal mode, respectively. In the case of the beam with two piezoelectric, the effect is very similar to the case with one piezoelectric. However, there is a difference in design frequency location according to the series and parallel connection shunt configuration. The conclusion of this work are explained by the analysis that the spectral element method and the transfer matrix method proved to be efficient for applications of passive vibration control and wave propagation with the resonant shunt circuit. The estimated wave number demonstrates attenuation corresponds to what is shown in functional response frequency. It is also observed that wave number and functional response frequency show the local resonant behavior at the same frequency as the vibration attenuation in with the impedance occurs. Thank you very much.